And we are live. Hello everyone, I got my ice water. I'm feeling fresh. I'm going to do the programming wheel in the master part model. I have Sam with me on the journey here. And I'm gonna change camera to Sam. There he is.
Hello everyone, I'm here.
And I wanna stay focused on the work today in this stream. So let's get right into it. Is your stream deck working, Hannes?
Yes.
Oh, good. Good. So for this stream, we're going to redo this programming wheel because this programming wheel is not correctly CADed according to the master part method. And in yesterday's streams, when my brain got into a halt by the end of a long, really fun day, I tried to make the gearbox here and I didn't know where to place it. And I realized when I walked home, I actually need to place the programming wheel first to know where I should place the programming wheel, the gearbox, excuse me. And I think the programming wheel will be another good lesson for me and for everyone watching in how to use the master part method. So let's do that. It was so fun yesterday, Hannes.
Yes, it was. And I can see that the chats are working. So I will try today to bundle up the questions a bit more. So if I see good questions, I will queue them up and Martin can answer them when he has some downtime. Let's now keep him focused on building a machine.
Alfons says good sound on all platforms and good image, so we're happy for that. So we can focus on the build. This is the blob model, which is controlling the master assembly. So this is the master assembly. And we took some major decisions yesterday on, for example, putting the conveyor belt inside the frame. And I'm also going to show you today what I mean with the skeleton clock design. So I loaded a skeleton clock here, and I think I'm going to take a lot of inspirations from skeleton clock designs, but I'm already derailing myself. Let's do the programming wheel.
Just before we start, I didn't listen to you do your intro. I'm sorry, Martin. Have you mentioned this is episode 400 of this long journey?
This is actually episode 400 of the Marble Machine journey. We have made this website, and all these videos is only the Marble Machine videos. It's crazy. But today is episode 400. So it's time to finish this project, I think.
Yeah, let's go.
Yeah.
Programming wheel.
So this blob is not the blob we're going to use. It's not correctly programmed of the programming wheel. So I'm going to start from scratch. So we're going to hide this one. Later, I'm going to delete all the features on that one. I'm going to start super fresh here with claiming the space for the programming wheel. So I'm going to think clearly on how to do this. And I think I can sketch the blob on the three standard planes, this right plane. So let's create a sketch on that plane. And I'm being meticulous with the naming of stuff. So I'm even naming all the sketch. So sketch programming wheel. I want to set this document up in a way that it's going to be really easy to work with it later and that it's not going to break over time. So slow is smooth, smooth is fast kind of approach. So on this sketch, we're going to make the blob. And so I'll make a programming wheel that is, say, this big. And the whole idea with these blobs is that I can change the position and the size of the programming wheel later, and the entire assembly will follow if I put my relationships and constraints correctly. So what kind of blob should I make here? The question is how many features how much resolution do I want here? And I think I've been thinking this through. I think I want to make a hollow cylinder just to be able to see through the blob. Otherwise, I can actually show that if I just extrude this symmetrically. If I just make the programming wheel like this, we can't see through it. And it becomes very... I think it becomes harder to play stuff and see how the machine will look. So I'm gonna give this blob one more feature. I'm going to offset the outer edge and kind of give it a shell. So let's say this is 25mm thick shell, and we're only going to extrude the outer ring. So let's change this extrude feature. So now you can see through this blob, and that's more how the machine will look. So we can already see that we have some interference. So let's fix that. I think we're not going to extrude symmetrically. We're going to extrude in 2 directions. And it's not important now. And that's going to be a lesson here. It's not important, these distances right now. That's not what we're deciding now. We're not deciding exactly how wide the programming wheel is. We're just claiming the space for the programming wheel. And again, this extrude feature, I'm going to name that as well. And we have the blob. With this blob now, we're going to create the real part, but we're doing that in a separate part studio that we're going to name programming wheel. And in this part studio, we're deriving the blob we just created. Hope everyone is having a great day. I'm feeling pumped and fresh today. Why is it taking 100 years? That's not a good sign. It's taking so long for it to find everything. So inside the master part, we're going to find our programming wheel blob under P. No, it's named part 64. We forgot to name it. I can derive it anyway. It's here. But let's go back and be very consistent with the naming. So down here we have part 64. We're not going to accept that. We're going to do programming wheel. And now in the programming wheel part studio, this part has now changed name to programming wheel. So now we want to add some more features to the programming wheel. First of all, we want another appearance for the shell. I think this color might be nice. We want some spokes and stuff, and we're gonna CAD these spokes so they're always working regardless the size and position of the blob. So we're gonna think very clearly about our constraints. I think we can sketch the spokes on the mid plane. And that's not this plane, so we need to create a mid plane. I'll do that with a mate connector. There. And let's add a sketch on the mate connector. Everything good on your side, Hannes?
I think so.
Yeah.
I think so. We have a lot of lovely messages in the chat. I've collected some that I will reveal to you at a later time.
All right.
You keep on sketching.
Good. we're gonna do some checkpoints. I'm gonna get to the first checkpoint of having this part ready in the studio, and then we can take in some chats. So now, and I'm new to this. I'm telling myself as much as I'm telling you. Now I need to be really clear about what kind of geometry I'm using. So I'm hitting U, and I'm gonna use this outside ring and the inside ring here. in the sketch. And then we're going to do some spokes that are related to this, that will always follow if I change size and position. So we do 60 degrees because we're having 6 spokes on the entire new marble machine. I had a huge debate with Alex CNC when we were driving in my car after our lovely excursion to the forest, Hannes.
Oh yeah, our hike.
After our hike, I talked to Alex for hours if the spokes should be 5 spokes or 6 spokes. And we landed...
Riveting.
We landed on 6 spokes. And sometimes I miss the look of 5 spokes.
Is the reasons behind 5 or 6? What's the reason?
6 is more classic, I think.
Okay. And is there a specific reason to why 6?
I don't know.
Okay. It's just mainly the looks. Okay.
I don't know, actually. It's I think other people know. So, but sometimes I think the 5 spokes of the MMX has a superior look somehow. Yeah. So we're not adding fillets in here because Derek says it's better to have fewer sketch lines and more features. And I did all these lines in a way that will respect the size changes later. So let's see. Okay, I'm going to extrude this. So now, where do I extrude this? We're not wanting this in the middle. We want it on the edge. And we want it to be in a relationship with this edge here. So I think we're going to have a starting offset. Let's see if I do this correctly. From this face. This is always a little bit... Okay, let's just do it. We're doing a new part. And we want the spokes to be 30 millimeters. Okay, something like that. It's fine. Made a mistake here. I missed a center shaft hole. So we go back to the sketch and we are just creating 20 millimeter shaft. I think the shaft should have been in the blob space. So let me actually, yeah, we're not adding the shaft in here. The shaft is created in the blob space. So let's go back and add that here. Because we have a point for a shaft here.
And please let me know, Martin, if you really need my help from here, if you need me to zoom in or something on your in your CAD.
Absolutely. There are some features I'm missing in the extrude command. That's why I fell silent here. I would like to be able to set an offset from a face in both of these directions. And I don't think I really can do that. Because I want this shaft to stick out a little bit. Let's rename the extrude feature programming wheel shaft. And we also have to rename the part. Okay, I did something wrong. I extruded it as a surface. I think I chose only the sketch lines. Oh, you see the shaft is hollow here. I just picked the wrong thing in the extrude. So we're going to go back to the extrude. And you see here, edge of programming wheel I picked. We're not going to do that. We're going to do face of sketch. Sketch curves. Oh, I need to go back to solid. There we go. I'm zoomed. So now we can rename this part in here. Rename programming wheel shaft. Maybe I should just short all that for prog. I think that's better. Rename prog wheel. I'm gonna rename the part studio as well. Save some space. Prog wheel.
Even in the naming convention, saving space.
Yes.
I love it.
Prog wheel is 2 syllables. Syllables. Thank you.
Sibylla.
Now we can go back to our the part studio for the programming wheel, and when we want to derive also the shaft, we need to not create a second derive because it won't accept that, but go and edit the first derive feature. So we're just going to go and find that programming wheel, prog wheel shaft.
I know where it is. There it was. There's the programming wheel.
Okay.
He's back, everyone. He's back today as well. Mischievous.
Nice.
You never know when it's going to pop up, and then it just disappears again.
Wilson.
Or did he?
Edit appearance. I appreciate Wilson. I'm just trying to not let him derail me.
This is the story of your life. He always appears.
So now, Hannes, in my sketch, I can also use the geometry of the shaft.
Mm-hmm.
Use. Did it turn up? Yeah. So the shaft is dictating from the shaft is created in the blob part. So now when we do this extrude, I can exclude the center, and that's what it did. Great. Let's see. Is this a new part? Yes. We're going to make this the dark wood color. I'm thinking about going for a brass dark wood look on this machine currently. We'll see if that adds up a long time. Perhaps we should add some fillets already now, because then I can make some more beautiful fillets, and it's easier before we circular pattern this. That's a bit too much. Large fillets are beautiful on the programming wheel. Let's add smaller fillets here. And according to Derek, you should add your fillets in as a feature like this and not in the sketch lines. That's probably an argument we can have. We're going to circular pattern this, shift for choosing axis, shift twice for changing number of times, and then add. And we have our... What do you think about the 6 spokes, Hannes?
This is a very controversial question you're throwing my way right now.
Yeah.
I don't know what I'm supposed to answer. The 6...
Making the fillets smaller.
Is it okay to not really have an opinion?
Yeah, it's okay.
I think this looks really good.
Okay, that's okay. I want to make the spokes a bit thinner, so we're going to make it 15 here.
Because if I just change the angle really quick derailment here. That is 6 spokes.
That's 6 spokes.
That is beautiful.
That was what Alex helped me design, that wheel, and we chose for 6 spokes. So yeah, okay. 6 spokes. We're gonna mirror this to the other side. So mirror. We're gonna do a part mirror. We're mirroring this part and hitting shift and choosing the thing. And now, my friends, comes the big moment when we're going to see. The shaft is not going to follow now, so I'll have to think a little bit about how to do that. But if I now go back to the master part and I do something crazy with the extrude here, I'll do this. Boom. Since I mirrored, I put something in the middle of the cylinder and I mirrored it over the middle. The spokes should be at the correct place, and they are.
Look at that. That is awesome. And that's the master part magic.
It's part of the master part magic, especially when we then later add this to the assembly. I can also do another demo. I can go into the sketch of this and I can do a crazy size. 4 meters wide. Even the spokes will look spindly. The spokes is working.
Wow.
So nothing is breaking.
Proper constraint.
Yes. And the shaft is not in that. It's due a little bit to the extrude command. I'll see if I actually dive into that now. We're gonna see. So obviously this is too big. Let's do undo.
Slightly too
big. All right, we got our part here. We haven't named these, so we're gonna name spokes left and spokes. Hit space for deselecting everything. Spokes right. I think we're gonna add one more feature. We're gonna add some programming tracks just for
the fun of it.
It's just a symbolic adding.
Because all of that hasn't really been decided yet.
No.
But
there will be some.
There will be a kind of programming feature on this.
So now, when I want to make another sketch curve here, I talked about this yesterday also. I'm not going to give this a value on its own, like 118, blah, blah, blah. I'm going to give it a relationship to the outside sketch curve to make it follow any later size changes. So I'm just doing a measurement here. So 10 millimeters, maybe the depth of the sketch curves. And then it will follow if I change the size. Let's try to extrude this. Shift E for extrude and so remove asymmetric. Let's do 10 millimeters. So we have our first groove here. And now it's a little bit interesting, Hannes. When I'm going to pattern this, I'm going to see if I can pattern this in a way that will always follow the size of the wheel. So I can drag it out. So we're going to linear pattern this remove feature. It's not a part pattern, it's a feature pattern, and it's this extrude I want to pattern. And I'm going to choose this direction, centered. Let's say we want 30 programming tracks. That was a bit too much for this wheel. 10, 15.
I like the look of that.
But I wanted to kind of, okay, I can't do that. What happens if I just do a lot of remove outside here? Will it accept that? No. Oh, wait, I think I need to do reapply features. Yes, okay.
Ah.
All right, I think this is...
That is cool.
This is not as good as I wanted to program it, but anyway, it's just a start.
Yes.
Now, we're not going to save because there's no save feature in Onshape. It's saving.
As a force of habit.
Yes, I'm hitting save by mistake. Now we're going to add this to our drivetrain assembly, which will add the programming wheel to the master assembly. And we're doing that by inserting the part studio. And Derek has taught us that we always want this checked. Insert entire part studio as rigid. That means that we insert it as a rigid group. And we're going to go down to prog wheel. We have an old prog wheel, which I'm going to delete soon, which is going to feel cathartic. Cathartic?
Yeah, cathartic.
And
You got it.
sorry?
You got it.
Cathartic. So now you can see this is loose in the
Yeah.
air.
You need to mate connect it.
Good, Hannes. Add mate connector to instance origin. We get this little magical thing here. We want to turn on the origin, which is here. We want to hit M, fastened mate. And we're going to choose that mate connector and the origin. And boom. We have the wheel in place.
That is so nice.
It feels so good because now I'm like, it needs to be. So here's the whole. Okay, let's first look at it in the master assembly. It should pop up here as well anytime soon. 3, 2, 1, pop. And now we can take this.
Delete.
Yeah. So now we're gonna clean this up. We're gonna delete this wheel. Delete from the master assembly, and we're getting cleaner and cleaner.
Wow. Wow.
So now, if
Good boy.
good hype man. So now if I want to change the position of this wheel, I'm not doing it here. I'm not doing it in here. I'm not doing it in the part itself.
You're going to the blobs.
I'm doing it in the blobs.
Woohoo.
So I can do whatever I want here. I just go to the sketch and I change the size, the position. And this will control the position in the master assembly, which is extremely fast and much better than what I learned to do in Fusion 360. I think you can solve this in Fusion 360 as well. It's just I never learned how to do it in a nice way.
This feels very intuitive.
It is intuitive, yes. Fast. And basically you can work on very high level, where should things go. And then when you want to work on detail, you go into the part studio and you work on details in here. It's really nice. All right. That's a checkpoint. We actually... I have queued up a lot of stuff for you, my friend. Okay, we can actually cross off the programming wheel. I'll do some CAD cleaning while you read me some nice chats.
Okay, so let's start off easy here with a lot of lovely people here from YouTube. Theo Hultberg 12. Good morning from Södermalm.
Oh, wow. Good morning, Södermalm.
Streetster from YouTube. It's Wednesday, my dudes. Oh, Thursday. That is right. We're live streaming now. We're going to be live streaming a lot. And we also have from YouTube A.E. Vince. Hello, guys. Cheers from Southern France. You have memories of Southern France, don't you?
Fond memories.
So lovely to have you guys from all over the world tuning in. That is fantastic. And from Twitch, the magic cookie 400 hype. That is right. This is our 400 episode that is Marble Machine related. We have made more videos, but that's like music videos and stuff like that, right?
Yep. Meanwhile, I'm naming all my Fifi.
And here's the first real question to you then, Martin. This is also from Theo Hultberg. Martin, how will all the shafts be supported? Will they extend all the way to the frame, or will they be supported some other way inside of the machine?
Good question. I think there will be small frames in the middle as well, because we want the shaft to be as short and compact as possible. So this frame is only a placeholder. There will be more frames in the middle. But related to the question is the skeleton clock design. So this picture is from the front of the skeleton clocks, but there are two main frames, and kind of all the shafts are going out to the two main frames. And I think I can take a lot of inspiration from this clean design. So both.
Both.
Yeah.
Great, thank you. And then we have a nice little super chat sending support our way. Badgi, a YouTube member. I've been to got on Patreon. Sending their love our way. That is awesome. Thank you so much for that.
Yeah.
That is fantastic.
We really appreciate the support. Rename sketch.
And from YouTube, MJ Sarah Chandra. We're done with Music Gears 3? Question mark, exclamation mark.
Very good question. I decided to do it the other way around. I needed the programming wheel in place because the Music Gears 3 are going to drive the programming wheel. So that's a perfect segue into the next task here. Let's do Music Gears 3.
That's gonna. We have more questions, Martin. You're not getting off the hook just yet. And Hadrian TV from YouTube wonders, will the live streams be divided into episodes, or will the progress of the live streams only be shown within the live streams themselves? We talked about this yesterday, but we will say to you today as well that we're going to be live streaming almost, the goal is all weekdays except Wednesdays. Because on Wednesdays, we're going to make a curated Wintergatan Wednesdays episode where we take... and condense everything down to a nice package showing the progress during the week. So all of those of you who can't watch all the live streams can get an update on how the progress is going. Is that right, Martin?
Yeah. So a 10-minute recap of all the live streams every Wednesday, 4 o'clock Stockholm time. So if you are sleeping while we're streaming, you can keep completely perfect up to date with the whole project 10 minutes per week. So Wintergatan Wednesdays is returning.
Oh yeah.
People
are cheering.
We've been experimenting a lot with the content, and I'm always changing my mind around, but now I think we're finding our paces here. And do you know something I need to do right away, Hannes? In this master assembly, I always struggle to know where the ceiling of my studio is. So can the programming wheel go higher or not? So I'm going to do something that I should have done a long time ago. I'm going to add the ceiling.
Add the ceiling. And while I do that, I'm going to say from Aiden, hello from 5 a.m. in Canada.
Oh, nice.
Love the progress you guys have been making recently. Been learning CAD right alongside y'all. And that is the highest of praise.
Yes.
People learning next to, especially Martin. I'm learning small stuff watching this. But it's so fun to hear that you guys are CADing alongside. That is fantastic.
Very happy for that.
And Alfons just wanted to test the chat on X. So we have the stream going on both YouTube, Twitch, and X. So the chat is working on X as well. So if you're following us there, we get your chats as well.
So now...
And lastly, just a nice little contribution from Braden. Just sending love for the live stream format. And Braden, we actually met in Rudesheim.
Oh.
A very nice Australian fella.
Of course.
Yeah, awesome guy. So happy that you're here as well. And
I actually saw
That's it.
I actually saw, Hannes, in my phone some videos from that from the party that night with Braden. Those videos are fun.
Yeah. I'm sorry. It was one more question. That's actually a question from Alex that you can answer while you're CADing here. Hannes, I'm not sure if you saw my question yesterday. Will Martin be reusing any of the materials like bearings and screws from MMX?
No.
No physical parts, but I saw a lot of questions as well yesterday, like, is he scrapping everything? Many of the ideas will be that you have learned through the first machine and the MMX will be used here. Stuff that worked, you're not going to change completely, right?
No.
So some of the DNA is still going to be here, but no physical parts is going to be reused.
Yep. No. The MMX is still... They're working on the MMX in Germany, so it's still... You can go and see the machine, I think, sometime at the museum. So we don't want to scrap that. And also, it's... Actually, it takes way more time to reuse. So I have the ceiling.
Before you go there, I just want to throw in another Very generous super chat here from Jackie the Deer, watching from New England, US, and a heart. And we sent our art back to you.
Thank you so much. I made the ceiling 3 meters, which is, what did we... I think my studio was a bit higher, or did I say 3 meters? So anyway, now as you can see, from the origin, which is the floor, up to this blob part, we have exactly 3000 millimeters. And I just want to add this ceiling to our master assembly. Can I add it straight in? As a visual reference for how high we can put stuff. The maximum height. So insert. I'm gonna insert. Okay, no, I need to create a part studio first. All right. So we need a ceiling part studio. Create part studio. Ceiling. I'm going to derive the new ceiling. From inside this machine. Oh, do you know why I'm not finding it? Because I didn't name it. We need to name our parts.
Yes.
Rename ceiling. It's okay also to do some chats in between while I'm thinking. Perhaps it's the questions, Hannes, that we should do between. So don't feel you.
We're trying to find a way of keeping it balanced to not derail you too much. So I think queuing up questions is good when you have some. You're not gonna have any downtime, but downer time.
Yep. Yep. No, that's good. See, now I found ceiling because I named it properly.
And Anders thinks it looks like you can expand the flywheel a little bit.
Oh, that's...
You got a couple centimeters, you know.
I love that people are so in tune with what all this is actually about. Let's add a ceiling and see if Anders is right. If we can expand the flywheel, we have to. It's the rule. It's like
that is the rule.
En passant is a forced move in chess. Yeah, Anders is correct. What are we doing wasting all this space?
Well, you don't need any space to like screw in screws.
No.
Stuff like that.
No. But what we are seeing here, so I'm very happy for this ceiling. Let's see if I can measure the distance now from the top of the programming wheel to the ceiling. I think if I hover over here, we can see 40 centimeters. So it's not a lot because the marbles are going to pass over it as well. Which means that I don't want to raise the programming wheel too much, actually.
Okay, but Anders also says, I can help you raise the ceiling.
Anders is on fire.
He's on fire today.
What I think... Someone wrote yesterday, why don't make the machine wider? And you know what I think perhaps, Hannes? I think perhaps we should put the base next to the vibraphone and we should make the machine a little bit wider to fit the drums and the shaker module. I think a little bit wider will be fine. But the programming wheel shouldn't be higher, but I want it more forward. So then the instruments needs to be lower. So let's do that. Programming wheel sketch. It's okay a little bit back there somewhere. You see we have a collision with the drums. Perhaps a bit more back. And let's move the drums out of the way. You see everything is disappearing when I move the drums. That's because the document isn't in a good order right now. The drums are created before these. I think I'm going to do it the other way around. Let's look how that looks in the master assembly. And soon we can go into Music Gears 3.
You see that I fixed the graphics. I'm getting there.
Beautiful. Oh, that looks actually really great. And again, don't pay too much attention to the skeleton frame. I think the skeleton frame is going to be a fun stream soon.
Yeah.
Where we go over that. And yeah, we are running into some space issues. That's fine for now. Conveyor belt is going to be one of the highest point of the machine. So I can see that we have some more space for the conveyor belt. And now, power of the master part model, I can just go to the blob, check this out. I can click the conveyor belt, I can find the sketch, it's unconstrained. Oh, I actually gave me a ceiling here. I'm going to put this on 3000. So that's the ceiling. Put it a bit higher. We need the followers also to have space for that. And we go to the master assembly. And the conveyor belt should update to be a little bit higher. I'm going to like massage this model over and over again to play around with it. So I'm building... Basically what I'm building is like a clay model, but in CAD, Hannes calls that clad, a clad model.
Yeah, copyright, Hannes.
Copyright, Hannes. So we have some wheels that looks better. We're gonna go over and make some wheels a little bit better looking later. I think this big wheel, but let's keep focused on the to-do list. Let's officially go into Music Gears 3, which reminds me, the programming wheel should have a gear, which I forgot. But that's simple because we're going to do that in the part studio. So let's go to the programming wheel sketch here. Boom. And we're going to make a gear, a symbol for a gear, a symbolic gear. And again, I'm not putting a value on the size of this. I'm giving it a relationship to our blob part. Let's say it sticks out 20 centimeters. So let's extrude this profile. We're gonna have a starting offset from this face. And we're going to have a nice wide helical gear of 100 millimeters. Boom. And did I do add? It should be new for new part. The color is giving it away that we did a new part. And we're going to edit that appearance to the wood color. Boom.
Perfection.
You don't understand how much Hannes is maintaining my mood. It's been doing that for
10 years.
When did we meet?
It's been almost, it's over 10 years ago because the original video was 10 years ago.
So the deal between me and Hannes is that he kind of lightly fixes my mood all the time. But what I do in return is that when Hannes has like run a race or something and is not in the mood of talking because he's pissed off with how it went, then I know to shut up. That's what I do in return.
That's the one time you shut up.
That is the one.
When I'm not in the mood, no one should talk to me.
No.
That is the rule.
2 times. Before he had his first coffee, and when he's not happy with the race time, with the time of the race he's running.
But do you know what makes me extremely happy, Martin?
Backers.
Seeing backers make me extremely happy as well, but seeing donations coming our way from beautiful people.
I knew
like
it was money though.
Yeah, of course. Marcin Kowalczyk sent a super chat our way with a question, or no, a statement more or less.
Oh, nice.
Do not limit yourself strictly to constraints of the box. Do not go over too much, but a bit is fine. Go for what works best, not what is form constrained. I guess it's gonna be at the end there.
Marcin Kowalski, I agree with you. Thank you so much for the support and the sentiment. Because we need to finish this, which means I've been keeping repeating this. If we have a crossroad where we can take a hard road or we can take a simpler, easier road, I owe it to myself and to all of you to take the easier road as often as I absolutely can. And I think that's your sentiment, Marcin, that don't complicate by saying it needs to be this or that shape, but like see what works and go with that.
Yeah, remember that this is a general shape identity.
Yeah.
It's not set completely yet, but in the ballpark.
Yeah.
So you have some wiggle room, some playroom.
You can leave that comment open because I'm actually gonna make a model right away. I'm gonna make a change to the model right away thanks to this comment. I'm gonna give us more space. I'm gonna move this frame a little bit. Let's see how I did this. I mirrored it. Okay, I'm just gonna add a transform and revisit this later. Translate by XYZ. So now I'm ruining the CAD structure a little bit, but just for inspiration, I think what Marcin just said is that if this frame needs to be there, it's fine.
Yeah.
You see how much more space we got?
Yeah, and the identity is kind of still there.
It is, right? And which is, I'm super hopeful because then we can put the base on the side. Let's actually, so now I'm CADing from viewers' comments here. Let's actually just move the pedals correctly. I'm going to this, I think, is the place to make this longer. So the box is outside the frame. Okay, now I need to go to the extrude and I need to... This extrude was so... I have lost control of this extrude. Face of... I'm up to the legs. We're not going to do this anymore. We're just going to do a distance. Blind.
A lot of comments now. And he is sidetracked.
Very shortly sidetracked. Look, I'm already back. So,
and people say way better. I see it. It looks better. Way better.
People like it. Let's see how this looks in the master assembly. We can breathe. We have space. If we need space, we can take the space.
So much room for extra activities.
Look here.
I saw someone comment that as well.
So I think it still looks like a cool sculpture. It's a little bit wider, but I mean, do you remember when I talked about making a kitchen wall like refrigerators, like just having the wall needs to be as long as it needs to be? That was in the beginning when I made ugly machines just to fit everything. I think Marcin's input is correct. If I need to move this over to the right to get everything in, I should. But then also on the opposite, if I need to kill some darlings to make it a cool, beautiful sculpture, I also should. So finding the balance, the trade-off between those two statements.
Yeah.
Should we fix the base? Or no, I'm sidetracked.
Don't get too sidetracked now. We're at Music Gears 3.
Yeah.
People are sitting at the edge of the seats right now.
Yeah.
But that was a really good suggestion.
Yeah. I just think I should show... I'm wondering if I just should move all this a little bit. Because now, because that's with the Music Gears 3, let's expand it a little bit. And now you're going to see the power of this model, because I think I can move everything with one arrow here. I don't remember exactly all the constraints. Look at that. Did you see what I just did? Boom. And then I want this to be to the left. So I need to go for the Higgins drive plane. I hope I'm remembering all the relationships. Almost. That's fine. Now we can make, thanks to this, we can make the programming wheel wider. So this extrusion can be there. You see the leg is a little bit. Okay, perhaps I should transform the legs right after the mirror. So now I actually made the programming wheel wider. And will it still work in the master assembly with all our CADing? I think it will. Let's see.
Fingers crossed.
Fingers crossed I learned my lesson, and check that out. I did.
Oh, so proud of you.
Thank you. The shaft is not following. We're going to discuss the shaft later. Did something break here? No. All right. Music Gears 3. This is Music Gear 3B, the driven gear.
Mm-hmm.
So I should actually name that properly. It's not called Prog Wheel Gear, it's called Music Gear 3B. And now is the question, should we do... Okay, so now I need to see where we'll add the mating gear. So let me think about how to constrain those. Okay, since I... The 3A should be on this shaft. I'm working my way backwards here. So I'm working in the other direction than what I did for the rest of the document. It's a little bit bad.
And the chat is already here, like Andre WRAAE. Space for the shaker and percussion.
Yes.
The carousel. They see where this is going.
Which is good, Andrew, that you're mentioning right now, because the wheel for those, for the shaker and tambourine, is going to be on, not on that shaft, but on this shaft, the output shaft from the gearbox, to be in time with the programming wheel. All right, so now is the question where we have a lot of space now, which is great. So now I just need to decide how to connect. The next task now is to connect this shaft with this gear of the programming wheel. I just need to think about how. I think I can. Should it be on the back here, or should it be in the middle of the frame? Probably in the middle of the frame. So let's use the gearbox, the ugly gearbox blobs that we did yesterday, and let's move them a bit out. So you see now the frame is confusing me. It jumps in when I go into previous features. You see that?
Yeah.
And that's because I made a transform feature later in the document. So I'm going to try to drag this transform feature in the timeline to right after I mirrored the frame. To see mirror frame. So now I think when I go into these features, yeah, then the frame is where we want it.
Good.
So that's better. Let's see how that looks. I'm trying to slow down. It's a bit of a challenge on these live streams, Hannes, that sometimes I need to slow down to do things properly.
Yeah.
And to not rush it because we're live.
Yeah. Try to not think about the hundreds and thousands of people that are watching you do this. It's it will go faster if you take it slow.
I just realized something. Yeah. I think what I need to do is to add the gears in the same way that everything else. Because now I see where I should put this. I think we should add this gear not in the programming wheel thing. So I need to redo that gear in the blob model. So now, music gears 3, we're ready. Let's start by creating a mid-plane for the music gears 3. And I never know what the best constraint would be here. I'm trying now to offset the gears from either from the gearbox or from the shaft. Yeah, I'm gonna offset it from this. We'll see if I regret this decision later. Probably. But then we can fix it then. First make it exist, make it good later. And I'm gonna name my plane. Plane music gears 3. So what geometry do we really know that we're gonna use for the gears? Well, it's this shaft. So I'm gonna hit U to project that geometry. Am I in the sketch? No, I'm not. I haven't created a sketch. So let's create the music gears 3 sketch. Music gears 3. Wilson is on music gears 3. Nice.
Yes, he is.
Now I'm hitting U. I'm using this. And I'm not using the programming wheel because the programming wheel position is following from the gears we're creating now. So we're gonna control the programming wheel position later. Everything I'm saying is as much to myself as to anyone else. So here's the first gear. And it's meeting the programming wheel gear. So let's do this a little bit small, 400 perhaps. That's actually quite large. Let's do this 1200. Or what was the size of the programming wheel? Exactly 1200, so let's make it a bit bigger. 1230. Because we do know that these two gears need to meet neatly like that. I'm gonna offset this because it's going to be like a little cylinder with hollow. Boom, boom, boom. Let's offset it 20. Boom.
Yes, a lot of booms right now. I love to hear it.
There's coming one soon because we're gonna extrude all this symmetrically, and we're creating the blobs. Extrude. I'm naming my feature right away. Extrude music gears 3. And we're extruding them 100 millimeters because they're our wide symmetrical. We have our blobs. And also now immediately we're gonna name our parts. So Which one is this? Rename music gear 3A and rename music gear 3B. And remember, inside the programming wheel, we did a music gear. Here. This one. So I want to remove that. And we're going to delete that. And oh, I have a delete part. I'm new to Onshape. Can I delete the delete part? Yes.
Oh, sweet.
Sweet. Let's just... I'm annoyed by this this too short shaft. We're gonna fix that relationship later. I'm just dragging it out there. So now, how do we find the relationship between the programming wheel and this gear? We're gonna change the order in which we created them. So we're gonna take... Don't I have a plane for the programming? No, I sketched it in the mid plane. Okay. I'm gonna take all the programming wheel stuff in the feature tree. We're gonna pull them to the very end of the feature tree, which means that now we created the programming wheel afterwards, which means now when we go to the programming wheel sketch, we can reference the position of this blob gear here.
Mm-hmm.
So we're gonna use that blob gear, and that blob gear is going to be... Perhaps I should do just concentric. Let's make that construction line. Concentric, was it Shift O? Shift O. Concentric. I'm so good at this.
Do you know how good I am at this?
Look how beautiful they align now. And so now we can't move the programming wheel. What we need to do, which is true in real life, we need to move this gear to move the programming wheel.
Mm-hmm.
I don't like this interference here. So let's change the extrusion of the programming wheel. Boom, let's make it a little less wide, like that. And now, to finish up, we need these gears to be in their own part studio. So let's create the part studio for Music Gears 3. Rename Music Gears 3. I'm gonna go into Derive. You'll see me do this over and over again, the same process here.
Nice. Repetition is soothing.
It is, right?
Yeah.
I love it. It feels like I'm not afraid of... When I'm busy with a repetitive task, I'm not afraid of dying. It's a little...
Habits is how we're supposed to live.
It's... I think it's true. Music Air 3A and Music Air 3B. I'm annoyed because I actually would like to have the shaft in here. Wood color. Boom, boom, boom. And if we want spokes and stuff, we can add it here. I think we're gonna add that later. We have the music gears. First make them exist, make it good later.
Mm-hmm.
Then we're gonna add these music gears to the drivetrain. The drivetrain is coming together, Hannes. Look at this.
That is pretty freaking awesome.
It's a serious start. Like, this is the first time that I feel that what I'm doing might end up on a stage.
Yeah, this is the stuff dreams are made of.
You're a hype man dreams are made of. Insert it as a rigid part. It's floating freely in mid-air, and that's why we're gonna add a mate connector to instance origin. There we have that one. And here's a great point that Derek taught me. There's a mate connector here at the origin. We don't want to mate the new mate connector to that mate connector. So we're going to hide that other mate connector. So we have a clean origin point to hit M for fasten mate to mate this to. And it flew onto, did you see how it flew onto the programming wheel? Whoosh, boom. Okay. I'm not excited over like how blobby this looks, but I'm excited that we actually finished the Music Gears 3, I would say, for your list, Hannes.
Oh my, am I supposed to go into graphic design yet again?
I think you need to go
to the start crank.
I think we're going to head over. I think we reached a milestone. Let's see in the master assembly. Oh, it feels so much better with the machine wider. It's not too wide, I don't think. This is promising for the music. I think the bass, like fronting with the bass. Okay, side quest. Let's fix the bass so we can see how that looks. Because something went wrong with the CAD of the bass. I didn't CAD it. But let's celebrate that the music gears are in.
Nice.
And let's go and see.
And do I have a good way of celebrating with you? First of all, I just want to highlight a question here from Mr. Poface's Clips. I'm sorry for pronouncing that. For good proportions, you should check the gold number rules used in architecture.
Gold number rules. Oh, I would love to. I would love if you could find information on that. It's not a golden cut like the golden ratio, is that?
I don't know. I just saw it sounded interesting, so I just featured it here. And also, as Fubuki says, enjoy the process. Taking it slow is totally fine.
Glad to hear.
And from Andre, big thanks to Hannes for preventing Martin going bonkers with CADing. Beers at end of day. And hearts. Thank you for the donation, Andre. That is very, very generous of you. Do you know what I think it's time for? While you set up the new work, I also want to take the time here now to also thank. We have such amazing backers that support this marvelous adventure. And I want to say we have a couple of new ones. This is from a couple of days ago. We're working on getting these extremely up to date. We're getting there, but these have joined in the last couple of days, and they are Agnon73, Axel Brattfoss, Christian Bauer Nielsen, Daniel Johannes, Duncan McNeish, Emil Mikkelsen, Juven Klorik, or Evan Klorik, Hannes Bake, Nicolas Vallone, and Ted Clemedson. Thank you so much for joining. And here we have all the wonderful backers in a nice little scrolling list right here while Martin sets up his next project, which is gonna be
the bass.
Fixing the bass.
Yeah, I'm if people understand CAD, they know how extremely badly I made this. I just took a picture from internet and I just traced it, but I didn't constrain it to the blob. So that's why things were falling apart. Thank you. So I'll fix that. But thank you so much for all the backers. The support is even better now because we're just doing what we need. We're not trying to maximize views anymore. So I'm putting the project before YouTube views and stuff, which feels so liberating. And the support from the backers it really gives us the peace of mind to do that. So thank you all very much. I did it so badly, Hannes. I'm trying to make this box fit on the base. I have an idea, perhaps, how I can do that better if I go to the master part. I'm going to redo this later. Sketch base. I sketched this on the ground. Everything here is bad. But anyway, let's make the blob longer. this long, so I can fit the little image on the blob. This is bad. I'm looking forward to clean up the instruments, especially this bass.
I just saw a famous person entering the chat here, Carlos.
Oh, nice.
I just hear a voice in my head. Martin is CADing a bass again. I just need to take a look.
Nice to see you here, Carlos. And Carlos,
Mr. Cyberbass.
Mr. Cyberbass. Carlos built a Cyberbass, was prominently featured in the Marmchin X series, and reached out to me on email the other day with a nice philosophic idea about. I think Carlos is on the same track as we are at trying to keep the new machine simple so we can finish it, not having the goalpost moving all the time. So thanks for being here, Carlos. And I think this bass is now fitting on the white block. So this should mean that the bass is actually okay now. Yes.
Look at that.
But it's not well made. Let's see now where the bass ends up in the master assembly. Now it ends up there. So let me see, is the bass floating? No. So the bass is probably mated somehow. And I'm thinking of... I can't move. Okay, I'm thinking of removing the mates here. So to be transparent, I'm not doing this according to the master part method now. I just want to move the bass temporarily. How can I delete this mate connector? I can't because it's in the sub-assembly. Let's do it like this. I'm going to delete the bass from the master assembly. I'm going to insert it again without mating it.
Mm-hmm.
So we can drag it around freely.
Nice.
We still want it as a rigid part. Bass. Is this it? Yes. So, yeah. Okay, now I can drag it around. So this is why we need to clean up a lot of stuff, Hannes. This isn't how I want to program the master assembly. But I just wanted to play with the idea to have the... Oh, it's nice. It's nice. This is very much like the first machine. The bass like to the right there. Look at all the space for drums now. A crash here behind the bass. The bass is going to be like playing with robot fingers and stuff as well. Kind of cool to have the bass being like bunk dunk 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 dunk. What do you think?
Yeah, that is great. That is great. Look at all the space.
I think I went a little bit like crazy with the... Oh, I can move the vibraphone as well. Okay. Yeah, it's getting wide, but yeah, it's what it is. It's wide. It's wide. It's great, but it's wide.
Yeah, but it's also okay.
I think so.
Yes, it looks right.
I'm scared.
And that's all I care about. I don't care about anything else.
I'm scared of the funnels being, the main funnel being like 2 meters wide. I'll hope that looks cool.
Scared of it.
But this makes it much simpler to have it the bass to the right of the vibraphone instead of... Because the marbles can jump. Oh, this is way better, actually. So it was actually a chat from... I actually don't remember the username. Marcin.
Yeah.
Who got me into making... And also a chat yesterday who said like, perhaps the machine can be a bit wider.
Yeah.
That opened up for this whole thing. So, feels good. Okay. That was the bass side quest. We've done with that. What's next on the list, Hannes? Start crank.
Start crank. And Wilson is already there. It's way ahead of you.
Wilson is way ahead of me. The start crank, everyone, is a new addition that Hannes really liked.
Yeah.
And good news is that this looks pretty simple to implement because we need to access this gear.
Mm-hmm.
And to explain to everyone is that these pedals will be very... in the beginning, it will not give a lot of... This shaft will move extremely slowly. That's what I noticed on my prototype, which means that even if I stand on these pedals, nothing is really going to start spinning. I need to get up the machine in some rotation to be able to use the pedals. So the start crank is going to have mechanical leverage over the pedals by gearing differently. Yes, this is correct. It belongs to this wheel. So then, you know what we should do? We should go into music gears. No, conveyor gears 1 and add... No, let's not do it like that. Let's add a start crank.
Yeah, and
now
it is difficult to paddle because it needs to lift the weight.
Yeah,
right?
yeah. In the beginning,
Yeah.
in the beginning, when we get up to speed, it's going to be more simpler. So let's make... I'm wondering if I should tack this wheel onto this wheel. No, I actually want to sketch this from the beginning. So I want to start crank. Do you want to start crank in the front here, Hannes, where it was in the first machine, or on the back here? Front, right?
Whatever makes you finish it in 40 minutes will be my answer to that.
Okay, we're gonna finish the start crank this stream.
Yes. So quick snappy decisions now to get it done.
Yep. That feedback. We're gonna have it on the front then. So can I use this plane? Yeah, I can. Conveyor gear plane. It's hidden somewhere. Oh, it's there. What's this little symbol? I've never seen this symbol. What happens?
What is that? A symbol?
A symbol.
Symbol.
Sketch. Start crank. Small gear. Maybe it's the start crank sketch. Yes. Sketch start crank. On that plane.
Eric Huska is wondering, crank also act as a clutch?
I don't think so. So I'm using this geometry of this wheel because we know it's going to meet that wheel. But maybe what you're referring to, Eric, is that the crank will not move when the human operator doesn't move it. So it will be ratcheted or like with a one-way bearing or something like that.
Yep.
So it doesn't rotate when it doesn't have to. Let's make another sketch for the actual crank. So here's the small wheel and the shaft. And we're going to extrude that. 100 millimeters. Symmetrical. New. And we're going to rename.
Yes.
I can rename it while I'll do it. Start crank small gear. Boom. We're also going to extrude the start crank shaft.
Just throwing this in here as well from Braden. Someone suggested on a video that the hand crank could be like a big removable key that comes out. You put it in crank and then take it out. That was kind of fun.
I think that some idea like that is great. you just like drag it towards you. It doesn't come. Oh, they want it to be like, oh, you can completely take it off.
Yeah.
So you
Chung.
you walk in
Yeah,
with
with
the
a
start
crank. With a crank in your hand.
That's pretty fun.
Put your keys into your car and just turn it on.
Extrude, start. That's a fun idea. Start crankshaft. It's all fun and games until you're like 5 minutes before concert. Where is the start crank?
Oh yeah, I thought I had it in my pocket. Where is it?
Someone took the start crank, and you're like, okay.
It will be on a pedestal on stage, like that. That will be the thing that all the spotlights are on, and you go and fetch the crank.
So now we do another plain start crank big wheel. Like tomorrow, I'll know what to rename this stuff. Just make it exist first. You can make it good later.
Yeah, this is what you think about when you go to sleep.
Honestly, yes. I'm listening to the Mar Machine podcast 24/7. It goes on in my forest fire brain. Here's the wheel. I'm trying to make snappy decisions now, Hannes.
Snappy but good.
Yeah. I shouldn't rush it to break the CAD. Sketch, start, crank, big wheel. And here I think we're gonna do our spoke trick to see through the disc, so it doesn't obstruct the visibility too much.
Mm-hmm.
It feels like we had a really focused stream now, Hannes, right? Doesn't it?
Yeah, we're trying to find the pace of keep you focused and also engage with the audience. We're getting there, people. But I see the chat, and it's impossible for me or Martin to answer all the questions that comes in. I do my best to curate it in a way that I feel like this will not derail Martin too much. So it's not. I see your messages.
But we're appreciating everyone being here a lot.
Of course, that is fantastic.
And also, I think over time, like Alfons is going to read some feedback. So, like, if there is feedback for the streams, I think Alfons will catch it. So we can get better over time.
Yeah, we have something to discuss on our weekly backers hangout.
I think like our main plan with making better content is to finish the machine and make content with the machine. I think this series is going to go more and more interesting the further the project comes. So I think progress is probably our best strategy.
Absolutely. And just, imagine when we have the camera set up in a new CNC room in your office and you start cutting plywood parts. Like, that is going to be banger content.
We mentioned
not that this is not banger content. I mean, we're probably the premier CAD channel online right now.
It's premier in dedication and in some metrics. Absolutely, I think. So here's our starting crank, and it's the blob again. So I'm not doing. That doesn't feel bad at all, actually. It feels like we have a lot of space for everything. There is a big chance that this shaft, which is also now too short, I have to go over the relationship for all the lengths of all the shafts. But this is the main power shaft. I do have an idea of lowering that closer to the floor. The limitation for that is the traveling distance of the main weight. So everything is connected to everything else. But I feel I would like some of these wheels to be a little bit further away from the music instruments. And I think some of the drums needs to be lower. So I think there will be a job to lower everything a little bit. But for now, this is pretty interesting. How far away is the pedals to? Yeah, it's only a meter, so that's very ergonomical. So I think this crank is in a good position. All right, let's create the start crank part studio.
And just quickly from Leslie Bradley, it's starting to look like the inner workings of a clock.
Yes.
You like to hear that,
Yes.
Martin.
We have to go to the clock then.
Look at that.
Which is...
huge inspiration.
Yeah, not exactly this one, but I'm going to start collecting images of skeleton clocks. Because I think what's smart with using skeleton clock is that they're designed in a tradition of a design, which means that over time, a lot of clock makers have solved a lot of problems and improved on each other's solutions, which means that there is history in this design, which means that if I steal some stuff from this design, I get a lot of work that a lot of engineers put in through history for free, kind of.
Nice.
So
let's keep going. You got 30 minutes to make a crank.
We are going to avoid getting cranky. Sorry, this wasn't just not fun.
Someone beat you to it. I saw it in the comment. Martin is getting cranky.
Okay, it's good to know that the audience have worse humor or as bad humor than me. We're gonna find now the crank parts. Was it starting crank? I've forgotten everything. What did I name it, Hannes? Start. Did I name it start? No.
Oh, sorry, I can't remember. The chat will remind us shortly.
Do you know what is happening? I didn't name the parts. How many times do we need to go through this? Look here. Part 69, part 70. That's why I couldn't.
Wow, slap on our wrists.
And I also see that there's only 2 parts, which means that this extrusion went wrong. I made an add. It should be new. So now we have 3 parts. Rename start crank. Small wheel. Small gear. Rename start crank shaft. Rename start crank big wheel. So now in the part studio, I'll find these parts because we named them properly.
There we go.
Let's see here. It should be on S. In the master part machine. I'm finding... Here we have them. I start to find the way of working with this master part model. It's actually really, really promising how it feels. Let's just make all of them gray. No, let's make this the wood color. I'm avoiding trying to make the parts too beautiful right now. What?
It just sounded so fun, like a really bad excuse for something. I'm just avoiding making them too beautiful right now. I could if I wanted.
Well,
I understand what you mean.
I could.
It just sounded really fun.
But we're going to add the start crank, the handle. I mean, I understand. Let's do this, and let's do a stupid handle, and let's do. So I find a midpoint there. Let's just make some I for coincident, boom. And then we're going to go with some kind of smooth sketch curve here. Like that. And here's a CADing trick for everyone out there. If things are symmetric, try to never CAD them twice. T for tangent. Here. Oh, blah. It's nice when I say nice CADing trick and then I just do something completely noob right away. So when doing symmetric stuff, try to mirror your lines. It's a good thing. Probably you should also constrain your sketches, but we're not doing that today. Up to face, this face. Yes. See, there's a little...
Oh, wow, that is so cute.
It's cute, huh? It's holder for the handle. And now let's extrude the handle itself. I mean, no one is impressed, but Hannes is impressed.
I am.
Now you know why he got the job, right? Apart from being the best hype ever, it's to sycophantically blow smoke up my ass on a constant basis.
A small puff constantly.
Small puff. There's no handle here because we don't add details in the blob part, but we're adding details in the part studios. So now we need to add this. Let's give that handle a better color, right? Something like that. Now we're going to add this to the drivetrain assembly. Oh, we have the flymall governor. That's for next stream, probably.
Oh, afternoon stream.
But that is going to be hard to put in. We're going to insert the start crank. It feels great to start having like all the shafts and stuff in, because then I can start a little bit seeing what needs to be done. It's floating free in space. I'm going to repeat all this so people learn the master part method. And we're fixing it in space by adding a mate connector to instance origin. The mate connector just appeared here. And then I'm going to repeat this as well. We're going to mate it to the origin point here, but we don't want to accidentally mate it to the other mate. So we're hiding that mate before we're hitting M for fasten mate, and we're mating these two. We're trying to be very disciplined. And talking about discipline, I don't like the color of this, so let's go and just fix that. For our dark brown wooden color, we're perhaps going for a brass. I'm hitting save, but I don't have to. We're going for a brass old wood finish, perhaps. The starting crank is interfering with the base right now, but it's at least in place. Okay.
This wider machine is growing on me.
You like it?
Yeah.
Oh, it's good because it's allowing a lot of fun things to happen if we can just make it a bit wider. How wide is it now? Let's measure between the frame. From frame to frame, 1600.
That is good.
It's not bad.
Isn't the crank awkwardly placed now if the pedals are gonna be there as well?
How do you mean?
Are you standing on the pedals to crank?
Yeah.
Okay.
So I can give power at the same time. But operation, I want all the controls here. So I'm thinking we could switch it over to the back.
Yeah, move it to the back.
You want to move it to the back?
I saw some comments about it as well, like perhaps move it further to the back.
What if I CAD'ed all this with a master part method so it's ridiculously simple to move it to the back?
Oh, wow.
Check this out. I'll take my unconstrained sketch. I drag it to the back. Oh, okay. I was going to brag how good I made this. And give me 1 second, and I think I will be able to. What is going wrong here now then, Martin? It went on the other. Okay. Good lesson here on how to build up your sketches so they don't. Let's just.
Okay, what have you learned?
Nothing yet.
But you're trying to figure it out.
I'm trying to figure it out right now.
Just like Memeplex says, when things break, opportunity to fix it right.
Yes. I don't understand really why the outside line is white. I don't think I have constrained the size of the outside line. Let's try to remove. So why is this? Because I also haven't constrained. Okay, that constraint was put in the wrong place, I think. Oh, I think okay, this is odd behavior. I don't think this line should be white now. But let's actually constrain the outer edge to make life simpler. Now 30. Something is wrong here because this line should not be. Let's remove the parallel. Often there's like a vertical constraint somewhere. Oh, look. Haha. I found it.
Okay. What was
this
the issue?
Little eye. Onshape creates a lot of vertical constraints when you don't mean to. This is vertical with something. With what? With the origin point. Look. It was so close to the origin point. So this, now we learn why my sketch broke. It was so close to the origin point, and that's why it moved the over to still be vertical. So you have to be careful to not accidentally. This was a great find, actually. Create these vertical constraints. So when we're gonna remove that vertical constraint, and we're going to hit B for parallel, and this line is gonna stay blue now until I constrain it. So it was one little accidental vertical constraint that Onshape added that prevented me from doing. So now we can do it again. What if I made a master part model that make it super simple to move it over? I can just drag this to the back and boom. Thank you, Hannes. Master assembly. The starting crank should have moved to the back. Something went wrong again.
Got a slice of pizza on there.
Okay, so now it's now you remember that I said that perhaps you should constrain your sketches in the starting crank. This is why. Or maybe I just. Okay. This is strange though. Why is this not following? I thought I was using. Okay, we're learning. We're making mistakes and learning. I don't understand why this sketch isn't following to the new position. Let's slow down here. This is important.
Yep. You still have plenty of time.
Thank you. Oh, it did. It was just an old... Oh, it just showed me. Yeah, the use is working. It's my unconstrained... You see, I didn't constrain these.
Mm-hmm.
So let's try if this sketch can... Let's just move this back. I'm just gonna move it back by hitting Command Z. I'm gonna see, okay, now the sketch is where it should be. But I'm going to constrain it. Which is obviously a noob lesson. It's blue now because it's not size constrained. And we're going to go with... This is a mirror, so I should only have to constrain one of these parts. Let's do 40. And let's hit E for equal. So equal radius.
Oh.
Everything is white. And our extrudes should like the situation. And now, I wonder if I can just redo, but I don't know what... Oh, is this redo? Oh, I found redo for the first time here.
Redo, okay. Yeah.
Control Y. Is it really Control Y? Let's try Control Y. Control Y. Ooh, redo.
Okay, but do we have pizza slice now?
I don't think so. I think this is going to work now.
Yes.
Almost.
Almost. It was rotating as well.
Okay, sorry everyone. I need to get my... Is this sketch happening before the move? Have I done them in a... Because what confuses me now is that this sketch should be over here. If I open it up, it's still there. Did I do... What's confusing me now is the order of stuff.
Mm-hmm.
Because I thought that the sketch I'm moving is before everything that happens in this part studio. Okay, I need to get this under control. Sketch star crank is really early. So what is then happening on this sketch? This sketch is following. I honestly don't understand why in... Oh, see, now the sketch has followed.
Huh.
See? For some interesting reason, it still goes bad. So let's first extrude. Oh, wait. I forgot this. I forgot one... oh yeah, it's the rotation. It's okay. This is something Derek told me. On shape is...
Ratziberg says this is a bug. Drop back and forward again.
I think it's not a bug. It's that on shape is confusing the Z axis. Because
Andrea Matera says it's just an update issue. The sketch is right. But okay, you go to what Derek said.
I think the update issue is correct also, but it's also when we rotated the wheel, on shape is now mirroring the Z axis, the up and down axis. Because you see, this is perpendicular towards this line here. So, what we need to do in the sketch, 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 what we need to do in the sk if we go back and redo, is that we need to do something that Onshape can't, so that Onshape knows what the Z axis is. Let's go back to here.
And hold your horses. Anastasis has wow, unnamed parts. Don't forget to name them.
Okay. Sorry everyone, but wait, do we have unnamed parts? Oh, it's a handle. Oh, in the part studios. Okay, I thank Anastasis.
Whoa.
We go back here, and we go back to this sketch. So now we need to make sure that Onshape knows what Z direction is. So I think I'm going to use one more thing. I think this was what was missing. I'm gonna use this edge, and I'm gonna put in a relationship here. Is that going to be enough? I wish I knew exactly why it flipped the Z axis. Let's see if that's enough. Redo, Control Y, we learned that today. Let's go back to the start crank. No, that's not enough.
Ratziberg seems to know his way around Onshape. Where possible, use relations instead of dimensions. These go through updates better. So
100%.
there could be something.
100%. And I've been trying to be kind of disciplined with that. This is a rotating issue. When parts are rotated, Derek warned me about this. I'm just wondering how I can tell, because now we have this, and the degree it really didn't care about that. We need I need to tie the sketch to the Z axis in some way. So again, let's redo. The sketch is happy here.
My memeplex, is the handle rotated or mirrored? Question.
Yeah, it's like mirrored, or because it changes the Z axis. So it's mirrored. It's like rotated 180 degrees because it's mirrored. I don't think this will help either. Like putting this in, it's gonna do the same. It's going to do the same, I think. Let's just try. I think it's gonna be the same mistake. Redo, because when we flip it over, it's rotating a bit.
Perhaps then don't do the redo. Do the action new again.
Is there someone writing that?
No, I just thought about that now. That perhaps it's stuck in the old habit.
Let's try that idea. I think it's gonna be the same thing. I'm very curious about this. I'm gonna drill down into this because this is something that we need to master for the master part method. So I'm doing the action over again. And it's the same issue here. Because I do want to be able to move stuff around. I can redo this sketch. I can go in here and fix it now, but I'd rather learn it. Okay, we're gonna go ask the Oracle. In Onshape, sometimes when I move parts, Onshape is confusing the Z direction in sketches. It flips upside down. How do I constrain the sketch to avoid on-shape flipping Z-axis upside down and breaking the CAD?
I'm just going to throw this in here from Tob. Wool. I believe it's the arc at the top right being constrained. When rotating, the handle is constrained to the top right arch instead of bottom left.
I believe it's the arc at the top right being constrained. When rotating, the handle is constrained to the top right arc instead of bottom left. I mean, it's, you're probably onto something. I don't understand really what I should do. So the oracle says fully constrain your sketch. Make sure everything is fully defined. A fully constrained sketch has no freedom to flip. Well, oracle is wrong there, but okay. Anchor the sketch to the origin. Constrain at least one point to the origin planes, existing edge. Or constrain geometry to avoid symmetric ambiguity. This is what happens, I think. Flips often happens when geometry is symmetric and the solver can't tell which side is up. That's exactly what's happening. A circle or rectangle only defined by size, not position. Add a dimension to one side, distance from origin, or a horizontal vertical constraint to define orientation. This is kind of what I tried. Be careful with transform moving parts. I'm not using that. Mirror without anchor can flip sides. Onshape doesn't store up as a fixed direction inside sketches. Instead, it solves constraints mathematically. Your job, remove alternate solutions. You know what I can do? I have an idea. Did you have another idea?
There's a lot of different ones here. Someone says here, oh, I bet you didn't constrain the rotation. From Fall Destin. The arcs are constrained to the wheel instead of the axle.
I can solve this by redoing the sketch, but I don't want to do that. I want to learn how to fix it like...
Again, the handle is in a different place compared to the wheel when it's moved, so a relationship breaks there.
Yeah, it flips C upside down. But the thing is that I can constrain it like to the origin point to make it not flip, but I want to be able to move this around. Perhaps just admitting defeat and redoing the sketch. How long time do we have?
We have 5 minutes.
Can you write a post-it, Hannes, to talk about Derek about flipping Z-axes? Because, for example, if I do the origin, if I add the origin somehow, I show the origin. When we rotate the thing,
Post-it done.
but the strange thing is how, yeah. We need to learn this, actually. I've had this problem before with the drums as well. I don't know how to... I actually don't know how to... I know how to solve it, but I don't know how to learn it. What happens if I just use everything?
Ratziberg says, look at the broken sketch and see what distance is not what you want it to be. Then add that dimension.
Yeah, I think it's not that simple because Onshape doesn't know what is up and what is down. But let's try that. Let's try that advice. I'm going to Control Y, redo the move. We're gonna go to the sketch. Because this is flipped upside down. So like everything is constrained, but OnShape is saying it's upside down now. So that's like this point is not constrained, but that point has nothing to do with it. This could be an argument for adding all the details. Okay. How to keep a sketch from knowing what is up and what is down when being rotated. And I think this it's important to understand what did it say here? OnShape doesn't well, what is that? It doesn't keep track. It uses construction geometry to define up. Constrain it vertical or horizontal. But that's the problem because it's mirroring. So it would still be vertical and horizontal. Okay.
Andrea, you only missed the constraint between the handle center and the center of the wheel.
No, that could be a good idea because then it can't flip it. I think Andrea solved it. We're gonna see. Let's head back here because then it will be impossible to.
Yeah, he adds no problem with up or down in that case.
It's gonna move the handle, but we don't care about that because it's just a wheel. Wait, I think Andrea got it right. Let's solve this for a fantastic ending to the stream. Instead of constraining it. So it is constrained, but it's constrained to the circle. If we instead constrain it to the center, 280 like this. Okay, I feel good about this. I still don't know how to make it not flip in some points, but Control Y, let's move. Andrea fixed it.
Oh,
thank you.
Oh, wow.
Thank you, Andrea.
Wow.
But see, like this line has flipped.
Yeah. So we're halfway there.
It's working, but we're still having this flipping issue. This flipping issue, Hannes.
This flipping issue. But I have on my post-it note that we're going to talk to Derek about this.
And we're renaming the handle part. So let's just do a quick wrap up. Thank you so much, everyone, for helping me live. I absolutely love that, to have a discussion drill down in some of the mechanics of the software.
Mm-hmm.
And we're going to go and look at this starting crank at the back of the machine. I think we stayed on target a lot this stream. There's a starting crank on the back. Feels better because I can have a lot of levers and stuff here. And we're only missing the flyball governor, and the drivetrain is complete, I think. So let's do that in the next stream this afternoon after lunch, Hannes. Thank you really, everyone. And thanks, Hannes, for being awesome here. And Alfons, the producer, who is away skiing.
Wow. That's what a producer does, right? Go on a ski trip.
I hope I can come with him, show him some snowboard moves one of these days. But yeah, we did a lot. We widened the machine. Yeah. We found out a better way to constrain the sketches to avoid the flip issue. We still haven't solved the flip issue completely. We just have to work around it. And we put a bass next to the vibraphone. And we took feedback from the viewers who helped me a lot this stream. So yeah, very happy.
Awesome. See you after lunch.
Yeah.
Yeah. Take care, everyone.
Thank you.
Thank you. Bye.